Hi, everyone. My name is Diego Angelino, and on behalf of the Nordic Center for Sustainable Healthcare, I welcome all of you to this event. And it's very important to let you know that this is not an isolated event. It's part of a more ambitious agenda that involves the Nordic Center for Sustainable Healthcare and a spillover of an initiative that was started last year by the Swedish Energy Agency, and many plans that we have for this year, and that involves not only our partners in the Nordic Center for Sustainable Healthcare, but our members and potential members in the United Kingdom. You will hear more about what is going on this year later on. And for today, I think that we have a very important and interesting event. Today we have the participation of key actors, not only unique expertise, professional, the people who are daily life challenging with the sustainability in the hospitals and healthcare facilities. We also have solution providers from Sweden offering you like some inspiration and practical knowledge about how to foster the transformation of the healthcare system. So let's start by know a little bit more about the organization who is behind this initiative. So I will give the floor to Daniel Eriksson, CEO and founder of the Nordic Center for Sustainable Healthcare, and then to Rachel Stancliffe from the Center of Sustainable Healthcare in UK. So they will talk about a little bit more about the organizations and about the plans that we have for this and the near future in UK. Thank you very much.
Thank you very much, Diego. As Diego mentioned, my name is Daniel Eriksson, and I work for the Nordic Center for Sustainable Healthcare. We started this 2015 as a subsidiary to a foundation, TEM Foundation here in Sweden. But me personally, I've been working with sustainability in different settings in healthcare for 20 years in many different countries and different settings. And what are we then? Some call us a network. Someone calls us a think tank. We prefer to be some kind of enabler. We make things happen when it comes to healthcare sustainability in different ways. And as I mentioned with the foundation, we are a non-for-profit, so a self-funded foundation in the background. We now have members that are getting quite a lot of members. We have members from I don't know, maybe up to 30 countries now, but also from 5 different continents, from New Zealand to Asia to South America, North America, Europe, and of course a lot of members from here from the Nordic. But the Nordic idea has spread, and as you can see, we have members from different sectors as universities, regions, hospitals, different types of companies, state agency, and so forth. So it's a big multidisciplinary network, and that is the idea. Because we see sustainable healthcare as, we call it this is my mantra, I always say, sustainable healthcare is a new industry, it's a new innovation area, and a new research field. Because sustainable healthcare doesn't belong to any of the old silos. Sustainable healthcare is cross-sectoral, it's horizontal, so to say. So sustainable healthcare spans from everything to design and construction of hospitals and healthcare facility, to life science with good environmental performance, to clean tech solutions with applications for healthcare. So you can apply this to the company sectors, you can apply this to different types of professionals working in healthcare systems, you can apply this to a university and different faculties. Sustainable healthcare is a truly multidisciplinary field and deserves the attention as such. We do multi different projects, and here are some of the reports from the last years. Everything from the UN development goals applied to the healthcare industry, to digitalization, to energy, to Nordic white paper on sustainable healthcare. Currently, we're working with a few, 3, 4 different European projects, from Horizon to Interreg to Erasmus. We have quite a lot of activities in India, working with different health facilities and hospitals and NGOs in India. We'll do some more this year. We have a lot of activities in Poland and so on and so on. So we're quite an international organization nowadays. UK, we have been working with together for many, many years now. We will hear more from Rachel Stancliffe in a few minutes, but we have known each other for, I don't know, 15 years at least, working both in the Nordics and in UK with healthcare sustainability issues. This is a reports area I want to stress a little bit today, since this is a part of a project from the Swedish Energy Agency, and we have done this in collaboration with them. This is a report share we call Nordic Know-how on sustainable healthcare best practices. We have done quite a many now. We're up to 8 different reports, and there are popular science-based study from best practices from primarily the Nordic countries on different quite narrow topics. We've been looking into everything from nitrous oxide destruction to geothermal energy to ventilation, lighting, cooling, etc. And the last one we had last year is about financing sustainable healthcare, or primarily energy and climate efficient healthcare. And all these reports you can find on our web page. I also want to advertise a little bit about our project, worldsgreenesthospital.org, where we showcase solutions that already exist and are in place and have a reference and someone you can call and ask if they work. We put them all together into one fictional hospital called Grönköping that you can access online to find solutions that are not it's not in the future, it's not innovation in the future, it's solutions that exist today that you can go and visit or see in Nordic hospitals. And we think that is also important to showcase that you can actually build the world's greenest hospital with solutions that already exist. Finally, I also want to invite you to the 6th Nordic conference here in Malmö, South Sweden, on the other side of the bridge, the first stop from Copenhagen, 15 minutes from Copenhagen Airport at Malmö Arena. We will have the 6th Nordic conference on sustainable healthcare this spring. These pictures are from the one this year, and we have a full exhibition of fantastic speakers and so on. We will have the conference on October the 15th, but this year, as last year, we will have a whole week of different activities together with universities and some of our members and so on. So we'll have many, many activities during this week, both on the Copenhagen side and on the Swedish side of the Öresund region. With that, I say thank you very much for your time, and I hand the mic to Rachel Stancliffe. Thank you.
Thanks so much, Daniel. Lovely to see you all today here. As Daniel said, we've been working together for a long time. Our centre in the UK is slightly different from the Nordic one, and so it's good for collaboration. Next slide, please. I'm not sure. Can I? Oh, I can do my own slides. Maybe no. Okay, just go back. Thank you. Brilliant. Okay, so the Centre for Sustainable Healthcare in the UK, we are a charity. We support the healthcare to lead and model climate action. And similar to Daniel, we've been working for about 15 years and collaborating with lots of different organisations to create a sustainable healthcare system. Next slide. Some of our work has been influenced by early findings about 15 years ago, which showed that the carbon footprint was not just in the buildings and the waste and so on, and not even just in the energy that we use in hospitals, but was a lot to do with the clinical care that went on in those places, obviously. And so we felt it was really important to engage clinical staff and healthcare professionals more generally in the work that we do in transformation. Next slide. So our programs have been helping healthcare professionals specifically within their organisations and to some extent those organisations and buildings as well, with methods and metrics for creating new sustainable models of care. So we have all these different programs within our team. Next slide. And keep going until the whole thing comes up. Thank you. So one of the main things that we look at is the triple bottom line. So how we measure value and how we create sustainable value in healthcare systems. So we think of outcomes for patients and for whole populations with the inputs of environmental, social, and financial resources. So that's a key concept for us. Next slide, please. And when we're thinking about how we get to net zero, which we've all got to do very quickly, obviously, we look not just at the really important things about energy, how to decarbonize our energy systems and the buildings that we work in, but if you click on through the next slide, we look at clinical leadership and innovation within that, that need for reduction in carbon emissions. So these concepts are about reducing carbon without reducing healthcare. So we don't want to reduce the healthcare we give, but we want the healthcare itself to be lower carbon. How do we do that? We look at prevention, patient empowerment, lean pathways, and low carbon alternatives, that's products and processes and so on, as well as the operational resource use in buildings. So that's just an example of one thing. So that's what we call sustainable clinical practice, as opposed to looking at the estates and clinical operations. Lastly, I'll just mention that although most of our work is with healthcare professionals on clinical care, immediate clinical care, we also run a program on green space for health, which is looking at how to use the green spaces around our healthcare settings for therapeutic purposes. So that can include prevention, but also rehabilitation and therapy in lots of different ways, both for mental and physical health. So that's a project we call the NHS Forest, the National Health Service Forest. So just quickly to mention on the next slide, we have a community of lots of different networks. So they are for specialties within healthcare. So we have about 29, 30 of those at the moment, and that's growing all the time. They are largely started in the UK, but now include people from all over the world. And next slide, last slide, I think, is I'll just mention briefly our courses, which are have been developed over the last 6 or 7 years and include introduction to sustainable healthcare, but then quite specific things about carbon footprinting and some of the practical solutions and so on that people have found are to be helpful internationally. And then some of the key concepts like our sustainable quality improvement that we have worked on over the years. So if anyone is interested in understanding more about those, I can talk about it more later. But for now, I think it's important to say that we have, as you can see, we've developed slightly differently from the Nordic Centre, much more kind of about engaging the people within the sector rather than the buildings and the energy. And so we're really looking forward to working even more closely with Daniel to develop that partnership over the next few years. Thanks very much.
Thank you very much, Rachel. And we have a few more slides that we haven't rehearsed, so we will just wing it, Rachel, together here. I think we can manage. Let's see if I can get the next slide here. We want to present a Nordic-British strategic partnership, but the idea is to expand this further on with other organizations like Centre for Sustainable Health in Oxford and Nordic Centre. Because, Rachel?
Because we have developed an awful lot of knowledge and expertise over time. We, to some extent, have helped to create this new field of sustainable healthcare. And we have very, very extensive networks together as our organizations have been working across borders, both in the Nordics and Britain, but also worldwide. Daniel mentioned some of his work in India and Australia, and we also have very good connections in America and South America. So yes, very much looking forward to that partnership.
And what are we going to do then, Rachel? We're going to act as accelerators. We haven't found the right name yet, but we're leaning towards something around accelerator. We want to enable hands-on learning, provide effective models of working, etc. And the purpose of it, we see that there's a lot of reinventing the wheel going on around, not at least here in Europe now. There is a lot of buzz going around green and climate and energy smart healthcare around Europe, and there's a lot of projects that are starting. But as Rachel really put it nicely when we talked a few weeks ago, if we're going to be able to do these changes until 2030, we need to accelerate this. We can't continue to reinvent the wheel and everyone is doing things that already been solved or been looked into, in some cases 10, 15, 20 years ago in some countries. So we need to build new knowledge, new projects, and so on knowledge that already exists. Or what do you say, Rachel, as final words for this?
Yeah, I think there's a lot which is still to know, but we do know an awful lot already. And we would really like to share that knowledge with as many people globally as we can in the shortest time possible to have the most impact that we can. We're both for not-for-profit, so we have a huge, we're very mission driven. And for me, it's the urgency of the need to change things very, very rapidly within the next 3 to 5 years that will really make a difference. And that's what we want to do.
And if you have any suggestions on names, please share them with us all in the chat. And I say thank you very much, Rachel. I'm looking forward to a continued collaboration for 15 more years, hopefully. Thank you very much. I give the mic back to my colleague, Diego.
Thank you, Daniel, and thank you, Rachel. Thank you, and I think that the audience also share with me this feeling of excitement, of looking forward what we can achieve together, not only the two powerful networks, the Center for Sustainable Healthcare and the Nordic Center for Sustainable Healthcare, but especially you, our members, our partners. And the event of today is part of these common efforts. So let's start, and I would like to give the word to Dr. N. Symons. That will be accompanied by the Professor Eames, and that we will present about the experience within the operative theater. So welcome, N, Dr. N, and if you want to share your screen, thank you very much.
So just to introduce ourselves, I'm Anne Symons. I'm a healthcare architect, and I've worked as a design manager on a construction site. And my background is on major acute healthcare projects. And together with Ian, we bid for, can we have the next slide, please? We connected through UCL Partners, which is University College London, with NHS Live Challenges. Now, what they were trying to do were put small sums of money which had come from the greener NHS to what could we do with linking the major hospitals to academia. So we listened to various presentations from the medics and the states, and we got 2 projects going with, one is UCLH, the hospital, the other one is Bart's NHS Trust. And the idea is they wanted smarter buildings, they wanted to minimize the energy use of idle equipment and technology, and they wanted to slash the bill by cutting the carbon. And some might know Johnny Groom because he's part of Green Anesthesia in the UK. Next one, please. So these are so in the academic field, it's myself, it's Ian, and it's also Duncan Wilson, who is from Connected Environments, analysing the data that we come up with. The next one, please. So we ended up with 2 projects we put in. I'm leading project 1, Ian's leading project 2. The reason for this was that the idea was to turn it down and switch off energy in an operating theatre. But in order to select an operating theatre that you could shut down, you need to do a sort of background research looking into the bigger picture of what the operating theatre types and designs are within these hospitals, and also an investigation into alternative ventilation systems. Next slide, please. So the two research projects are called Rethinking Operating Theatre Suite Design to Reduce Energy Usage and Achieve Net Zero Carbon. And the other one is Turn It Down or Switch It Off, an evidence-based approach to change perceptions with ventilation and energy efficiency. Next one, please. So the Introducing Change aims, each trust has elective operating theatre suite selected to what we have in the UK, HTM Hospital Technical Memoranda 03 on ventilation and Health Building Note 26 on the design of operating theatres. To place sensors in these rooms to measure the effects of setting back and turning off the ventilation systems, a set of protocols to be developed related to the operating theatre control panels and their interaction with BMS and BEM systems, a learning programme for staff, an outline of responsibility to be set up, and an investigation as how the proposal can be applied to the other operating theatre suites within the trusts and the wider NHS. We know there's thousands, over 3,000 operating theatres that could be part of the study. The next one, please. I think as part before, the carbon footprint related to the operating theatre, the building energy accounts for 10%, anaesthetic gases for 5%, water and waste for 5%, and medical equipment for 10%. Next one, please. The factors that affect the operating room are energy, the ventilation, and the prevention of surgical site infections, automatic doors, equipment, it's the main bulky items, theatre lights, delivery systems, robots, anaesthetic gases, nitrous oxide, and there's also water and waste in terms of scrub facilities and dirty utilities. Next one, please. Something to look at is the fact that an elective operating room is in use and the interpretation of it. If you say to somebody it's Monday to Friday, 5 days a week, that implies 71% operational use. If you take the Monday to Friday and you're only operating from 8 till 8, you're only equaling 35.5%. If you stretch it to Monday to Sunday, it's 50%. So the message that comes out from this is that operating theatres are actually out of use more than they're actually in use. Next one, please. And this is where it comes to a difference, and the next explanation is that many academic papers refer to the operating room rather than an operating theatre suite. And there's a fundamental difference between the UK and the European US practice. The UK the room is part of a suite, an anaesthetic room, a scrub up, a prep room, and a dirty utility. The European model tends to be either a single operating room or one that has preparation facilities attached, and the other facilities are in the corridors or they're remote. Next slide, please. In the UK, this is what we have to comply with. We have to comply with HTM on ventilation. It was part 1, part 2, which is operational. It was revised in 2021. HBN 26 was produced in 2004. It's currently being revised, but it's still not published. We had the two are tied together through an activity-based system, which was transferred to the 2013, and it hasn't really been updated. So the next one, please. These are the requirements, and in the UK, it's measured in terms of air changes and nominal pressures. The next one, please. So to go to the ventilation control, local panels, according to the HTM, say that they can be on, set back, and off, and that switching a system off when not required is the most energy efficient policy. The issue is that And it also says there a ventilation system should not be run at full output just in case it may be needed. And that is what we're being faced at the moment, is that the ventilation systems in some hospitals are running 24/7. Next one, please. So, Ian, would you like to describe these?
So, I mean, the challenge for reducing the cost is not just how the space is used, which is when the ventilation system is on, but also the efficiency of the ventilation system. So one of the interesting things that Anna and myself have done, have gone around Europe, and we've seen a very nice system from Avidicare that's a much more efficient system than the laminar and the turbulent flow system. And also people kind of forget that buildings are serviced by plant rooms and plant systems and air handling units. And so we have to look at their efficiency. And the surprising thing as you go around looking at these multiple hospitals is that there's a huge range of variation across these systems. So for instance, in many cases that the ventilation system is not put in a setback position because no one's asked to do it. There are some hospitals that have been able to turn their systems off, so they need a protocol for that. So that involves management. In many cases, the ventilation systems are over ventilated, particularly on the laminar flow system. Then there is a discussion going on, as many are aware, whether or not laminar flow is effective. And surprisingly, which is a bit shocking, is that many plant rooms don't have heat recovery systems. So they basically heat enormous amounts of air from ambient, which might be 5 degrees, 10 degrees outside, to 20, and that whole stuff is just dumped outside. So it is an interesting problem. Next slide. So there are various ways of turning things off, and so the problem that we face is that in many hospitals you need an additional process to be able to turn things off. There's no kill switch. It's not like a home, you go in and turn a button off. And so the challenge is to set up that protocol. Now, as the speakers have said in the initial discussion, there is a lot of experience out there. So, and there are a couple of hospitals that have had that experience of putting in these management protocols, modifying their BMS, modifying their plant system so that they can turn things off. So what we're doing at the moment is this big thing that was discussed at the beginning of this webinar, is this idea of communicating that very excellent expertise that exists in one area of the NHS into other parts. And so that's what we're trying to do, to try and to kind of kickstart. So there's a lot of goodwill in that area, and that's what we're trying to kind of take advantage of. There is a lot of potential for innovation on that side. So as a mechanical engineer, we're identifying opportunities there that are going to, through innovation, to improve the efficiency of these systems. The costs are frightening. They're just frightening. So typically the numbers that we're getting back are they're costing about 50k a year to run each theatre, and as Anna says, there's a couple of thousand theatres, and so if we can reduce the costs by 50%, just purely by being able to turn them off, then it's a huge saving for the NHS and pushes us towards that net zero goal. Next slide. So the interesting thing is that we've got the three types of ventilation systems. The one on the right, Peter's in the gentleman on the left of the right-hand figure. So there are three typical ways of ventilating a space, the special spaces. So laminar flow system, which isn't technically not laminar, but this idea of generating a uniform descending region of clean air. Second one is turbulent. So the solution to pollution is dilution. That's a typical infection control specialist, where you mix the air rapidly, dilute it, and remove any contaminants. And then there's this thermal control air system, where very clever modern method of creating a colder plume that descends over the patient that's very clean. The challenge that we face, and challenge that other countries have faced, is that their codes of practice don't allow for innovation, and that's certainly the case in the UK, but there have been a good progress in Holland, and Sweden's obviously a very good model for take advantage of these new engineered systems. So what we hope to do is to argue a case that the HTMs can be tweaked so that we can have these much higher efficiency, more modern, innovative systems available. Next slide. Yeah, so the issues to do with, there is a big question about infection control to do with turning things off, but there is evidence around there. Basically, the point is if no one's in the room and the ventilation's not on, then there is no risk. The two challenges of bringing a space up to the necessary conditions is that you have to clear what air is in there out. And that's done in a couple of minutes. So 20 air changes an hour means that in 3 minutes, the air is generally mostly replaced. So after 10 minutes, 15 minutes, it's pretty clean. The biggest challenge, as the estates managers will probably point out to you, is that it's the thermal conditioning of the space. People don't like to go into cold rooms, so that generally takes 30 minutes. So the idea for those hospitals where you can do it, turn them off, and when you need to, turn them back on 30 minutes before they're required. Next slide.
This is
back to you. Yeah.
We can skip that one. Basically, I know we're back with time. So what we've got here are a few slides just to show some of the different theatre suites in the project scope. Next slide, please. Again, this one is just showing the ones that are in. This is what is important for understanding outside the UK, is that we have these 5 rooms. And 2 of them have the same air change rates, the operating room and the preparation room. The dirt utility is negative, the anaesthetic room is less than the operating room, and in many cases, the scrub room doesn't actually have a door into the operating room, so the air will be flowing between the 2 spaces. Next one, please. This is part of our initial study, in that the HTM describes this 5-room suite, but we haven't really found many at the moment. People are sharing dirty utilities. They're putting remote dirty utilities. There's anaesthetic rooms being shared. There's barn theatres where you've got 2 tables in the one theatre. And so trying to say, if we shut off if we reduce the ventilation in the operating room, what effect has it in the surrounding rooms, or can we take some of the surrounding rooms away? There's not a lot of standardization, even though we're claiming standardization. The bottom 3, the operating room with the adjoining preparation, we've seen in the Netherlands in the IMechE clinic, and it is a very clean space. And the big difference between that and the previous ones is that, if you like to call them wet and dry theatres, our theatres have water within the vicinity of the operating table. In the Netherlands and in the single operating theatre room in Germany, there are no water facilities within the theatre. So there's no airborne from the water. The isolation theatre suite is an experimental one that we are trying to develop. So that would also not have a water outlet. Next one, please. We've concentrated on what we've described as medium complexity theatres, the standard operating theatres. We've taken out of the study ones that are with high complexity, where you've got hybrids, where you've got a major piece of imaging equipment in the theatre, and we've taken out the low complexity ones, where they're more like described as an enhanced procedure room. Because the minute you write on a drawing that it's an operating room or operating theatre, then it clicks in for the full HTMO3 ventilation requirements. And we know that for a lot of these, that is not necessary. Next one, please. These are just a few pictures from the studies that we've done into different theatres. These are UK theatres. Next one, if you just want to go through them, this one is in Queen Square, these adaptations. You can see these rooms. Now this is the single operating theatre, and it's much more it looks much more sophisticated than the early ones. And the next one is from the University of Amberg-Weiden, where the professor has an operating theatre where he can he can do tests. So he can test the air quality, and the room adjoining it is actually a full-blown ventilation plant room. So it's a proper testing facility. Next one, please.
1 minute, please. Just if you know.
Yeah. Next one. This is a standard hospital in York. We described as ultra clean, but again, it's not as sophisticated. The next one. This is the St. Martin's Clinic in Nijmegen, and it's probably the most high-tech we've seen. It's the operating room. It has an adjoining preparation room, and this is the scrub bay, which is in the corridor. So it's on the principles of clean room technology. So we now need to compare CFU counts between that and, say, the British equivalent. The next one, please, is if we're looking at these models and we have separate anesthetic rooms, what are the outcomes? What would it look like if we removed an anesthetic room, if we introduced sliding doors, and if we adopted a concept of dry or clean room technology? So that's what we're trying to do. It's a very wide remit in a way, because of the fact that the standard, it's not just an operating room in the UK. Thank you.
Thank you very much, Anne and Ian. Very interesting, and we can start to see the interoperability and the compatibility of the systems within the healthcare. So thank you very much for your presentation, and please, to the audience, just keep your questions in the chat. You can use the chat or wait until the end of the presentation so we can have like a joint discussion with everyone. And now I would like to change the geography of the event and hear about an experience in Sweden. So I would like to welcome Anna Vesterberg from Region Skåne. Welcome, Anna. So the floor is yours if you want to share your screen, and I will mute my micro now. Welcome.
Thank you very much, Diego. I hope my audio is okay. Perfect. Okay, so my name is Anna Vesterberg, and I work as unit manager for technical development at Regionfastigheter, Region Skåne. Regionfastigheter is Region Skåne's property department, responsible for hospitals in 8 municipalities with a total area of 1,300,000 square meters. There are 21 regions in Sweden, and Region Skåne is Sweden's southmost region. The regions are governed by political elected elected by the county's residents. So the photograph in this image shows the Center for Forensic Psychiatry, situated in the town of Trelleborg in Region Skåne. So I am going to talk about our expectations, conclusions, and what we have learned from the project of building this building up to date. Forensic psychiatry applies primarily to the care of patients with psychosis in combination with addiction problem. However, a large part of the care is about co-planning with municipalities and other healthcare institutions, which is a prerequisite for a successful discharge from closed care. So the patients enrolled in this facility are enrolled through the criminal justice system, and the fact that the patients are often enrolled for a very long time also means special and high demands on a good physical and hygienic environment. So the Forensic Psychiatry Center was inaugurated in 2016. The planning began in 2013. There was a large need for new premises due to legislations and with new requirements for, among other things, fire safety, new safety rules such as control of what was taken into the building and better control of electronic communications, also meant necessary changes in the previous facilities that were not possible to accommodate. The facility maintains safety class 2, which means that it is safe for escape, but not for exempt. So in connection with the forensic psychiatry, there are also other activities in this building, such as an administrative court, which need secure and appropriate spaces to conduct sessions. So the court settings entail that patients do not need leave the premises for court hearings. The Forensic Psychiatry Center is built to renew and develop the forensic psychiatry care in Skåne, a modern healthcare facility where the importance lies both in creating a good working environment for the staff and a healing environment for the patients. So the high safety requirements required a dense concrete construction, and it also contributed to energy efficiency. So when the planning started, there was initially a demand that the building should be 20% more energy efficient than legal requirements. But since the high safety requirements required this dense concrete construction, and it also contributed to the energy efficiency, the decision to build the center as a passive house was made quite early in the process. And from there, the step to making it into a plus energy house was small and found to be financially profitable. So the decision to go all the way and make it a plus energy house was made during the pre-design phase. So in order for a building to be classified as a passive house, it must be well insulated. It must be very tight, airtight, and it needs to have a high heat recovery. So therefore, the building was highly insulated in the climate shell, floors, exterior walls, and ceilings was made with thick insulation. And the insulation is basically doubled in comparison with conventional technology. And not to leak any energy, the windows have a very good U value. And because of the clientele, the patients that are being in the place, for safety reasons, the windows also had to be specially made and have a high safety mark. To achieve the passive house level, the 4 housing bodies are narrow in the wards where the rooms are small and they need a lot of daylight, while it is deep in the rehabilitation and in the administration areas where the rooms therefore are large, and the windows need to be large as well for adequate daylight admission. So this way, the enclosing facade surface is minimized and the energy cost decreases without the daylight being impaired. The building is partially heated by the people who are staying there, and the shape of the roof interacts with optimal locations for solar cell panels and solar heating collectors. All the indoor lighting has daylight control to make the best use of the sunlight outside. And the building has been supported by geothermic wells consisting of 2 warm and 3 cold wells to ensure a low demand for bought electricity through heat pump technology. The geothermic heating and cooling systems in combination with floor heating and air conditioning ensures for a good comfort as well as a safe environment. The effective ventilation has a heat recovery of at least 80% and variable airflow throughout the building to ensure that the air quality is good. And all the materials were chosen with care to have at least the least possible environmental impact and to be robust and expedient. So the site also has a wind power plant. The wind power plant is 25 meters high with a wing diameter of 14 meters, and it has an output of 25 kilowatts. It produced 55,366 kilowatt hours during 2023. Solar cell panels, there are a total of 1,282 square meters of solar cell panels, and they produced a total of 180,318 kilowatt hours during 2023. And 130 square meters of solar heating collectors of the roof produced 19,430 kilowatt hours during 2023. The solar heating collectors were not fully in operation during 2023, and therefore the produced amounts of energy was not so high. So the project had a budget of 500 million Swedish kronas. The outcome was approximately 25 million Swedish kronas below budget, and the cost landed on 37,880 Swedish kronas per square meters. That is 2,682 British pounds per square meters. And the solar cells, solar collectors, and the wind power made up about 1.24% of the total budget, so not very much. The decision to change there was a decision not to change the requirements, the set requirements after the procurement, and that was one of the reasons that we managed to keep our budget. So there was no changes done to the building after the procurements. One of the important lessons we've learned by this project was dimensioning. It is a passive house, so it requires a relatively high internal load to keep the need for supplied energy low. But this building does not fulfill this. It has a low density of people in relation to other care facilities, and doesn't have much other internal loads. The lighting is energy efficiency with LED technology. Doesn't have a lot of other internal loads besides people and sunlight. So we had to it had to have extra heating. So the need for supplied energy was greater than we calculated. That's one thing that we have learned in this project. Also, to be able to go one step further to a plus energy house, you need large areas in the right solar directions. So you have room for solar cell panels, and if possible, you need space for a wind turbine on site. This is not always obtainable in urban settings. We have tried to look into these possibilities in other projects, but it has not been obtainable. So the building with the passive house standard, though, it has a lot of advantages. So there's a much smoother and more pleasant indoor climate, and we have a low need to add energy. We made a calculation that the additional cost to build this with passive house standard was approximately 9%, while operating costs decreased by 50%. So there is a lot of advantages into doing this. Though it's a complex buildings with all the different systems, so the commissioning of the building was not easy. We have encountered unforeseen setbacks since we took the building into commissioning, and these have been managed along the way, but we are not quite there yet. As you can see in these pictures here, the output of energy use in 2023 was 31.1 kilowatt hours per square meters, and the produced energy 21.3 kilowatt energies. So we did not fully reach the passive house standard this year. We have in a previous year back, but we are. It is many things that have done this. So one of the things that contributed to us not being able to reach the passive house standard was the extraction of heating and cooling from the geothermal wells. It was this extraction was too low, so the calculated charge of the wells did not occur to the extent that was assumed and calculated, and therefore now we only have 2 out of 5 wells in operations. So the dimensioning of a facility is very important, but it's also very complex when building a healthcare facility. This was my last picture. So thank you.
Thank to you, Anna. Thank you for this excellent presentation. Super important, and I think that well, we will discuss it later, no? But the importance for energy efficiency and climate smart to think about even from the beginning, from the design phase and so on. So thank you, Anna. And I think that with that idea on mind, I will like to give the floor to Dr. Helen Meese and Dr. Laura Hent from the Institution of Mechanical Engineers, one of the latest organizations who have been expressing the interest to join our network. So we are very happy to and looking forward to the collaboration. So Dr. Helen Meese and Dr. Laura Hent, the floor is yours. So you can just start.
Thank you very much, Diego. I'm just going to share my slides, so please bear with me a second. Excellent. Well, good afternoon, everyone, and thank you very much for inviting myself and Laura to speak. I do appreciate that we are running behind schedule, so I will try and speed things up as much as possible. And so I will avoid doing any overbearing introductions to myself and Laura, but we're happy to take questions at the end of this session today. Our presentation focuses on that sustainability in healthcare, and obviously the reason for us being here, and the vicious circle that the healthcare sector has found itself in and is perpetuating as a result of technology innovation and medical advancement. We will, of course, be looking at this through the lens of engineering, and we'll highlight what the engineering community is and could be doing to break the circle, this vicious circle, and create care solutions for the future that are environmentally, societally, and financially sustainable. And now, despite the all-consuming mission of the global healthcare sector to do no harm and protect society from illness, disease, and death, it is, according to the NGO Health Without Harm, the 5th biggest polluter on the planet. And that puts us somewhere between Russia and Japan, I believe, in comparable emissions. And indeed, the healthcare's climate footprint is estimated to be about 4.4% of global net emissions. That's equivalent to the output from 514 coal-fired power stations, making it as significant today as a problem as waste in the food sector. And it seems ludicrous then, certainly to us at the IMechE, that to think that the act of caring for those suffering from health conditions brought about by environmental pressures is both directly and indirectly partially responsible for their condition in the first place. You may have seen this kind of data before, but evidence shows that for more than 70% of the carbon emissions in healthcare are derived from manufacture, transport and disposal of goods and services, food and agricultural supplies, medical devices, and hospital equipment and consumables disposal. with energy consumption in healthcare facilities adding a further 12%. The operational emissions and emergency vehicles account for about 17% of the carbon footprint. And it should be noted that this doesn't include the emissions from patient and visitor travel to and from appointments and treatment, which is difficult to measure, but we can safely say it's somewhere between the tens, if not hundreds, of kilograms of CO2 per person per day. So it's quite clear then that the healthcare sector, both clinical and technological, must address these alarming contribution to climate change in two potential ways. First, by finding more effective ways to treat those made ill, injured or dying from environmental impacts. And the second, by drastically changing the way that healthcare services are delivered. And the engineering community is already playing a leading role in the implementation of initiatives within the healthcare sector that will certainly tackle sustainability and some of the net zero challenges. And these are predominantly focused on 6 of the categories that WHO outlined in their report a few years ago. Waste materials, for example, don't just refer to the byproducts of the clinical care process, such as surgical waste and single-use materials, but also e-waste, the electronic devices that reach the end of life and are just discarded because something better comes along, for example. By way of another statistic, in 2021, when delivering patient care, the NHS staff used 10 times more water than the average office worker. And that's an annual cost to the NHS of £60 million. But it's not just wastewater that's generated through the care of patients, but through activities in the healthcare supply chain itself during manufacture and also runoff into rivers and oceans. Frequent pollutants in hospital wastewater include pharmaceutical products, which kind of makes sense, microorganisms, heavy metals, cleaning products, and other chemicals such as organic halogens and free chlorine. Emissions, as well as a result of procured goods, direct energy use in healthcare facilities and patient and staff travel, which I've already mentioned, all contribute to the issue. And while there's no definitive global figure for this, the NHS calculated that in 2012, it produced 24.7 million tonnes of carbon dioxide emissions just alone by itself. So to put that into context, it's roughly the equivalent of the total emissions of the entire country of Croatia in that same year. While in the West, we consider the management of toxic chemicals and pharma to be of the highest standard, there are many countries, mainly low-income countries, who don't take that approach and are still using or processing large amounts of hazardous chemicals, including things like mercury, polyvinyl chloride, flame retardants, and volatile organic chemicals. Particularly during the manufacture and use and disposal of medical technology and equipment. And this is increasingly becoming of concern to the engineering community. And finally, in these 6 points, resource consumption, which is a really tricky one, because it's not just about drilling down into how we keep the lights on in a hospital. We have to think much deeper than that. Indirect consumption, for example, from electricity generation or the production of procured healthcare products is pretty significant. So if you think about, for example, disposable cotton items in healthcare, used in everything from surgical gowns to swabs, the embedded environmental impact because of those items is because cotton is a high water intensive crop to grow. So we have to go beyond the actual object itself, but right the way back into the process of manufacture. And when you consider that there are 20 million unique items of medical devices on the market today, and the number of resources that they consume in terms of manufacture, transport, and operating life, the indirect pressures on the environment are becoming just immeasurable, really. So now I feel like I've kind of thoroughly depressed everyone with all of these kind of awful things. But let me share with you a few recent achievements that have begun to address some of these issues. And for this purpose, I will focus on the UK's National Health Service. We're very privileged in the UK to not just have a point of care health service, but a national service that provides significant investment to life-changing technologies and medicines. The paradox for the NHS is that while it provides over 7% of the UK's GDP, buying goods and services from over 80,000 individual suppliers, it accounts for 4% of the country's carbon emissions. However, in 2020, as many of you will probably know, the NHS became the first national healthcare service in the world to commit to delivering a net zero service by 2040 through its Greener NHS initiative. To achieve this, it not only had to change the way it cared for patients across its entire network to opt for more sustainable methods of treatment, but also it had to radically transform the way it selected and used products and services, driving change across its entire supply chain network. So 3 years after they set this goal, are they progressing, or has this become yet another environmental white elephant? Well, I have to say that they are doing very well so far. The NHS as an organisation and its staff have wholeheartedly adopted the initiative, which has now become embedded across many aspects of care. And I thought I would just share with you a few of the NHS's ongoing projects and their outcomes, just as a taster of what's going on. This particular one is something that I'm absolutely fascinated with. It's a point-to-point drone service, which has been run from the University of Southampton, which is right on the south coast of the UK. And just off there is a very small island called the Isle of Wight, which relies on the mainland for hospital provision of services and so on. Typically, to get chemotherapy treatments to patients on the island would take anywhere up to 4 hours, because they would have to go by car, by ferry, by car again. Now, with these drones in service, they can deliver point-to-point treatments within 30 minutes, which is having a significant effect on the way that patients are treated, and is reducing the amount of CO2 that was being consumed. This particular one is a catalytic converter for gas and air within a hospital within, I think it's St George's in London. Nitrous oxide is 3 times more damaging to the environment in terms compared to carbon dioxide. And one of the things that St George's have done is look at building a conversion unit which was able to break down any harmless gases into oxygen and nitrogen before they're released into the environment. They believe so far that the devices have eliminated 99% of the nitrous oxide that would have been released into the environment. I'm going to skip through this quite quickly, but I'm more than happy to talk about it in a little bit more detail just to save some time. But in order to achieve their goals, the NHS is requiring its supply chain to buy into its own green initiative. And to do this, they have developed a plan which started in 2022 and is now pushing forward so that they can help their supply chain commit and drive forward sustainable changes within their business structures. Bearing in mind that in the UK, about 90% of suppliers into the NHS are small businesses, less than 10 people. And some of them, their only customer is the NHS. So this is quite a challenge for some of these suppliers. And by 2030, every supplier that the NHS takes on, every contract that they sign, the supplier will have to demonstrate their commitment to the carbon emission process through the Evergreen Sustainable Supplier Assessment. Now, just to kind of give you an idea of the reasons why we as engineers are so finding this so important, like our clinical brethren, engineers have the power of life and death when it comes to designing and developing medical devices. And just like clinicians, we also have a Hippocratic Oath, which is in the form of a code of conduct. And we agree not to compromise the welfare, health and safety of society, and to safeguard the public interest. And we do this through our accreditation body, the Engineering Council. And they have recently introduced 3 particular requirements on professional engineers that we have to be very aware of during our careers and the development of the technology that we work on. And so for good reason, this is why we are driven to speak more openly now about the issues that face healthcare. And I hope that in the work that we do as an institution, that we can drive this forward. Now, I appreciate we're getting close to time, so I'm going to hand over to Laura, who's just going to talk to you about the imminent report on sustainable healthcare that we are planning to put out later this year, and the reasons around why the IMechE is so strongly engaged in this process. Laura.
Thank you, Laura. Just one big favor, just if you can just run a little bit, because we are short of time.
Yeah,
so,
I can see we're at 14 minutes already, so we'll go as fast as we can.
I'll go quickly. So to summarise, I think we've already heard from engineers today, so I think that's great. We believe that engineering will be essential to really help the NHS and institutes around the world really to achieve their net zero and sustainability goals. Helen, if you move to the next slide, there does remain a significant issue for the NHS around the workforce. There's just not enough engineers working directly in the NHS to sustain these challenges in the long term. And while industry might be in a position to produce the technology needed, we need to think about a more efficient management of that technology within hospitals to make sure we're getting the best out of them and we're not causing more issues elsewhere. We also have an opportunity to encourage more people to take up engineering and technical roles in the NHS and industry to increase engagement with their clinical colleagues, but also help patients, carers and the public understand how they are benefiting from medical technologies and respond to these concerns that society may have around sustainability. And that would help to grow the already impressive pockets of success into a system-wide sustainable process. And lastly, we need to increase the pressure on governments to create a more coherent strategy for healthcare. It's more than just paying lip service to the climate crisis, about providing that long-term planning for global climate events. And then Helen, last slide, I think. So we're from the Institution of Mechanical Engineers. For those who don't know us, we represent over 115,000 global engineers, with I think approximately 3,000 working in biomedical engineering. So we have a vested interest here of engineers working in the medical and healthcare sector. Over the winter, we've been developing a report with Helen looking at the substantial impact engineers have on the healthcare sector, specifically across the UK. And this report that we'll be launching in April makes several challenges that acknowledges those challenges and makes several recommendations. The headlines are on the screen, but if you have any thoughts on these, my email address will be at the end, so please do get in touch. But it's all about how we can facilitate the innovation in the healthcare system, support it to come through to the market, how we integrate it in the healthcare sector, so how we get more engineers in, and how we support industries, particularly those small companies, like Helen said, measure and account for their carbon emissions. So in conclusion, the global impact of climate change is undeniable. Air pollution, infectious diseases, poor food quality, weather, energy. It's all just the tip of the iceberg, which the global health care sector also faces. And to leave you with the last message, engineering is playing its part in addressing many of these issues, but it needs more of an emphasis. So yeah, my email address is on the screen, so please do get in touch if you're interested in the report that's coming out.
Thank you very much, Laura and Helen. And sorry again for the time, but we are looking forward to the results of the report next April. And the good news is that you will hear more about the Institution of Medical Engineers through our webpage in NCSO and so on, once that we complete the process that they became members. And now let's hear about some of the solutions. And I will give the floor to our dear friend and member of the Nordic Center, Niklas Berglöf from ClimaCheck. The floor is yours. So if you want to share your screen and do the presentation, thank you.
Absolutely. Hopefully you can see my screen. Good. Perfect.
Yes.
Yeah, so I'm Niklas from ClimaCheck, and I'm going to talk a bit about optimizing HVAC and R system in hospitals. So the core of the ventilation, so to say, heat pumps and chillers, that's where we're focusing. And also giving insight in how this can save energy and in hospital lives. So our main focus is air conditioning, heat pump and refrigeration and performance analytics of these systems. But to give you a more wider view, how big is the electricity consumption of these systems? 20% globally, and in buildings, it's approximately 30 to 60%. I would say in hospitals, it's probably almost 50% of the total electricity consumption. And what people tend to forget when it comes to indoor ventilator or indoor climate, it is business critical. In hospitals, if you lose air, if you get too humid air, you lose the sterilization. So it's very important to have control of these systems. And we can see that it's usually 10 to 30% saving potential, which means that these systems are not really controlled or they are forgotten. And ClimaCheck today, we have over 200 customers. We're looking into 20 million data points everywhere, every day, analyzing system performance. Our engineers are looking in systems in US, in Australia, in Europe, and we have customers within hospitals, food stores, supermarkets, municipalities, everywhere where you have heat pumps and chillers. And I'm going to focus on hospitals now. So let's start what you can actually achieve. This is a case from US. Hospitals are very sensitive with the data. So we have multiple cases, but we can't present them. So but we see similar all over the world. So this is from Banner Health in USA. And initially, this is from the pilot. We looked into these two chillers and could see that they have quite large potential to save energy, but they didn't have, it's not expensive to fix. So after the optimization and the change of some small components, they saved more than 600,000 or more than 500,000 kilowatt hours per year, and to a cost of less than 20,000 euros. So they decided to move on because when they got control on the chillers, they could have more surgeries. They didn't need to cancel this as the systems were running continuously. So this is a hospital chain in USA with 25 hospitals. The last picture was from one hospital, and then they have looked into another 10 hospitals and see what can we do with these 10. And what they saw was that they could, of course, save a lot of energy, which meant that they saved almost $4 million per year, or 14 million kilowatt hours yearly, which of course makes a huge impact on the economy. But what they also could see is after optimization, when they analyzed the chiller and heat pump performance with our method, is that over a 6-month period, 24 new problems arise, which usually between 10 to 15% decrease in energy efficiency, but some had bigger impact, up to 40%, which meant that they can save almost 100,000 or could avoid increased cost on 130,000 a year, which puts a big focus on actually maintaining performance. And what we learned over thousands and thousands of systems is that right temperature is not a good measure of performance. As we could see before, there's a huge saving potential, but no one cares. No one, I shouldn't say people not care, but as long as the right temperature is reached, there's no problem if there. I mean, no one knows if they could save 10 or 15%. This leads to increased costs, increased breakdowns, and an unpredictability that is very undesirable. And how can I say this, or why am I saying this? Yep, I mean, we have been working with this analytics since the patent was taken 86 and we were founded 2004. And since then we have built up or put in more than 100 man years of analytics and experience into our method. And what we found out is that the majority of optimization is done in the ventilation or distribution, so the hot side or the cold side, where you look into, you mentioned before that you go full airflow or you don't want to go full airflow because of reasons. What we do is that we look into the core, the chiller, the heat pump. How is it affecting if you go do this ventilation, if you add this machine in the hospitals? We would see how that affects the energy consumption in the heat pump and the chiller. And this is done with our unique method that is based on thermodynamics. And this is how we would present it. So on a very high level, you can see system efficiency index. Without any knowledge of the system, you can look at it and say, okay, green is good, red is bad. And you would directly know, okay, this system, it is green, so it's good, for example. But if it's red, you can look into the different components. So you know, are we losing refrigerant, which is a high CO2 emission factor? Is our compressor bad? How is our evaporator working? So you get that insight directly to the system. And this, of course, creates another factor. You can work with predictive maintenance. By following performance continuously, you know if, okay, this is the temperature outside, this is the expected performance during this ambient temperature, or if you have geothermal during this operation. And you know directly, are we losing performance or are we maintaining performance? And when you know that, you can avoid performance drift. So you find deviations directly, and then you can fix them before it's expensive. And of course, knowing that you have a problem, at one point it will be noticeable, but you need to identify them. And this is what we do. We identify them directly when they happen, or when the deviation happens, actually causing the problem. And what we've seen is that it's not one problem it's not one problem that is like majority of the causes. It's quite even divided. And this is statistics from roughly 100 systems over 3 years. So you could see that the flows are 11%, the refrigerant is 16. By pinpointing this quickly, you know directly where to work. And of course, this saves money because you avoid the failures and you reduce the maintenance time. And this, we are awarded for this multiple times, but most recently, NREL, that is the National Renewable Energy Laboratory in US, concluded that our methodology and our method to identify problem is alone in the capability. So they divided the multiple system into 4 grades, and ClimaCheck is alone at the 3rd grade, and no one goes to the 4th grade. So why is this important? Yeah, it is to reach, and this is important to change how we work today. Data collection, it's not a big discussion today. Hospitals need to know how to send and receive data if it's leaving the site. But it is the analytics. There's so much data collected, and there's a temperature here, a temperature there, doesn't give information. So we need to add analytics on the data. And this is what ClimaCheck does. So you take your data, we analyze it, and give actionable information that is used to optimize and then maintain performance. And of course, when this is done, you want to monitor the performance so you don't get new problems. And this is changing the market quite substantially, I would say, because today you have the chillers, the heat pumps, the core of the energy or cooling or temperature, so to say. You have the property owners or hospitals, and you have contractors. All are in different silos, causing a lot of problems because you have scheduled maintenance, you have emergency service, you have lack of time. All of this ends up to the perfect storm where no one have time to actually look forward. You're always fighting to fix the daily problems. And this is where we see that new methods creates new opportunities, that all the data collected today makes it possible to move away from this reactive way. I have one slide left, Diego. So we're moving away from these old ways of silos where you work reactive. You work with more new services, predictive maintenance, energy optimization, sustainability reporting, and this changes dynamic how to work. So what does we do? Or to sum it up, ClimaCheck, we supply the analytics. We help multiple companies around the world with giving information that helps ESG reporting, so you can include the chiller and heat pumps. We enable predictive maintenance. Our unique analytics gives you the information you need to actually avoid problems. Research says that you can avoid 70 to 75% of the failures, which of course goes directly to reliability into the systems, into the hospitals. And then energy side. We see that it's often possible to save 10, 15, 20, up to 30% on average, even more in some cases. So you get control of your energy and your maintenance and your reporting. That's why it's very important to work with performance analytics, which I can help you with. Thank you very much. And I will be here afterwards if you have questions.
Thank you very much, Niklas. Very important. I think that is very basic importance, not only to generate data, but to transform that data in information that you can use.
The value is in information, and we start to go to a point where data is available.
Yeah, thank you very much. And with that, I will give the floor to another solution, another friend from our members in Nordic Center for Sustainable Healthcare. And I would like the floor to Peter Ljubetic from Avidicare. The floor is yours.
Thank you, Diego. Yeah. So I'm very shortly just going to tell you about our system here. We're a company based in Lund, Sweden, and we do operating room ventilation. So basically what we heard from Niklas here, this is then bringing the air into the building and then dividing it into different rooms. And this is specified on one room in the hospital here, and that's the operating room in this case here. But how to provide better operating theater air quality and comfort with less energy. Just to give you an idea of what we're speaking about here, I mean, from a money perspective, is that we have around, just move my, we have about 5 times higher, and these are numbers from Sweden, hospital-acquired infections high normally announced compared to traffic mortality or deaths, basically. And I mean, you all know how much is invested into traffic, but into the healthcare, I mean, yes or no? See, my screen is not moving. Here we go. So what we do is operating room ventilation. So we deliver the last piece into delivering the air into the operating theater. There are different ways of defining what kind of quality you want, and normally you have a threshold of 10 CFU, which is colony forming units, which is basically bacteria measured per cubic meter. Below 10, it's an ultra clean condition for infection sensitive surgery, just like orthopedics, thoracic surgery, neurology, or you do less intensive surgery, which would then be a threshold of 100 CFU per cubic meter. And that would be some kind of endoscopic surgery, or whatever, ear, knees, nose, throat, whatever. What we can deliver is ultra clean conditions in the whole room. Normally today, with the traditional solutions called laminar airflow, you will only have a clean zone of normally 3 by 3 meters. And in this zone, you have to keep the patient, the wound, the people working, sterile dressed, instrument table, and there is no chance in the world that they will fit into this area, especially not when you're looking into orthopedic procedures. It needs to be comfortable for the staff as well, and you need to save on energy. This is a picture of an installation at the new hospital in Malmö, NSM, where they're currently building 17 operating theaters, 12 prep rooms, and 2 hybrid solutions, all equipped with the Operagon system from Avidicare. This one on the left side here is also integrated with a Danish company called Crona regarding circadian lightning, so day rhythm lightning from morning to during night as well there, or the mood. Hybrid solutions, I know Anne mentioned earlier here on that they will not focus on this one here, but hybrid solution, hybrid operating theaters, they are very difficult to ventilate as there is so much space needed in the intermediate ceiling, between ceiling and joist here, for the technology for those X-rays apparatus. Just a few more installations. Latest one from the US, University in Medical Center in Rochester, St. Martin's Clinic in Nijmegen, which I know Anne Ian also visited here. And the special thing with this clinic here, they are globally ranked as the #6 clinic in the world for orthopedic procedures. And this clinic only does, I think they do run 3,500 to 4,000 orthopedic procedures per year. Well, marketing pictures is one thing, but how to design a ventilation system. And I mean, this is the reality in an operating room. And normally operating rooms are validated, the performance is validated at rest. That means with no people in the room, very often they remove the lamps from the ceiling just to have a better airflow and then to measure the particles. It doesn't really say much about how you need, I mean, when you need a system and how does the system perform with people in the room. And that's why it's important in the future also to measure CFUs, I mean, which is then colony forming units. So you know exactly how much bacteria do you have in the room during surgery. And it's pretty easily done, I mean, just like with particle measurements also. This is from the UK. It was mentioned before, the operating theater norm for is the HTM 0301. Here you need a certain speed at a certain level. So at 2 meters level, you need a certain speed at 0.48 or 0.46 meters per second. So that means that the air with the classical laminar airflow is released with somewhere 0.4, 0.45 meters per second. And then at the patient wound area height of the operating table, it should be somewhere 0.23 meters per second. And this is actually our biggest challenge on the UK market. How? Because the system we are using is temperature controlled, so it's driven by gravity based on cold air sinks. So from the ceiling, we release the air with approximately, almost no speed at all, so 0.005 meters per second. And then gradually the airspeed increases as we fall down. And we reach the same level at the patient at the wound area, which is then 0.23 meters per second, but it's kind of reversed to the normal thinking. But this creates a lot of challenges, and to change the norm will take at least somewhere between 5 to 7 years. But you're allowed to do exemptions in the UK norm, but it's very difficult for people. They are afraid to do exemptions because, nobody really got fired to follow a norm here. Regarding performance also, there are studies done. You can, we try to minimize the risk for minimal surgery, surgical site infections. And we have a study with 1,000 patients before and 1,000 patients post, reducing the surgical site infections from 3.1 to 1.1% just by exchanging the ventilation system. And that concludes my presentation here. I was trying to be quick, and all the videos, smoke videos, can easily be found on YouTube. Thank you.
Thank you very much, Peter. It was a very nice presentation, and you can check more about Avidicare, of course, as part of the Nordic Center for Sustainable Healthcare. And now, this event is about bridging Sweden and Great Britain. So I would like to give the floor to Anna Crona from the Swedish Chamber of Commerce in the UK. So please, the floor is yours, and thank you for staying a little bit more with us.
Perfect. Okay. So just quickly then saying we are here from the Swedish Chamber of Commerce, and great to be invited here. I'm Anna Crona, then I am head of business services here at the Swedish Chamber in the UK. So I've been working with supporting tech companies and companies expanding to the UK with different growth programs for the last 5 years, actually. So Swedish Chamber is a business platform founded by business for business, and it's the ultimate business platform for connecting Swedish and British companies and entrepreneurs across the North Sea. So we are also, as many of you here, a not-for-profit organization to help businesses establish, grow, and develop. We represent 450 plus businesses across all sectors and industries. So we are generalists, and we help small, newly started businesses as well as the likes of IKEA, AstraZeneca, and obviously we help them in very different ways. The way we would like to add value is to strengthen the Swedish-British relations and also adapt to focusing on certain themes that are current on for us and for most of our members. So one thing is what we call the new relationship, which is basically when it started from Brexit. We also cover now the new leading up to the election, but also that for in this circumstances, what is interesting is the MOU, the Memorandum of Understanding. That's a stronger relationship between Sweden and the UK. We also focus on climate change, sustainability, innovation and technology, and we have also started to work with science and innovation technology, having had a high-level delegation visit from universities to see how they can develop the education on AI, in interdisciplinary AI in education, higher education, and post-graduation. And people culture as well. Just to say also, the Swedish-British community, the way we work is not just the larger company, but also with the market entry programs, establish and scale programs, and into innovation, industry, and academia. And the way we do it is most of those programs are for free. And we work with partnerships with organizations like the Department for Business and Trade in Stockholm, British Embassy here, Team Sweden Business, our Swedish Business Trade Organization, Business Sweden, and other members in our organization who are interested in getting an exchange or meeting up with newcomers from the UK, from Sweden. When it comes to the life science space, just to mention a few, we have had Dokla from startup to now Europe's leading virtual hospital. They started in a market entry program, and then we have seen them grow through different, of course, through their own abilities and skill set as well, but now happy to have them as part of in our organization when we do the growth program, talking about lessons learned and giving advice and contacts to newcomers entering the UK. We also have Doctrine, online consultation platform used by NHS, Elekta, radiotherapy treatment solutions, who have been growing by acquiring similar or complementing businesses, Cree, Levy, Mindler, and AstraZeneca, just to tell you a few. And the reason for these companies to be part of is from the beginning, of course, to get connections and see and learn from others, and having a network to stay together and updated with. But also, so our USB is our 450 plus members, as well as their partners and their connections. And so in our wider network on the British market, these communities, these people or organizations are willing to share their experience, guidance, and their contacts. To tell you a little bit more on business services, the department that I run, we have different market introductions, like we are going to work now in together with EY on a strategic tech partnership with doing a Welcome to the UK, where we invite startups, scale-ups, SMEs to understand a little bit more about the UK in EY's headquarters in Stockholm now in March. We have a Swedish-British Connect that we try to connect with companies that are coming over to visit an international conference in UK. We had yesterday EdTech companies coming over, 10 Swedish companies who are here to meet at BET, the international conference there. We do partner searches and matchmaking, and then the ecosystem exchanges that we talked about, that we'll talk a little bit deeper about. We also have a lot of incoming calls, just to people that ask questions. How do I get the bank account? How do I get the best recruiter for my business? Those kind of things that we also have a lot of inbound questions, and we have referrals that we do without any costs. The ecosystem exchange is what you can expect, is a Swedish-British connect together with entrepreneurs, stakeholders, investors, and industry partners. So we select together with a partner 7 to 15 selected scale-up of SMEs to be coached through masterclasses, inspirational speeches, and get the opportunity to meet other stakeholders, founders, and entrepreneurs to prepare them to take their business to the next level. In these circumstances, life science, we're working now with the Invest in Skåne to take the food, no, not life science, that's food actually. Life sciences, we work with, we have worked with the Department for Business and Trade and our partner in AstraZeneca, where we also had a delegation visit, going to visit the clusters in Oxford and another one in the cluster in Cambridge, to get to know that a little bit deeper and what it takes to get established there, what kind of support that you can get. We have PropTech, and there we have also had different heating and cooling companies coming over as part of that we did just last year. And then FinTech. So just show you a little bit about the diversity and who we bring together for this. So the reoccurring sessions in this is, of course, the lessons learned by successful entrepreneurs that are always so interesting to get to know and share network contacts and experience for what is important to do to establish yourself on the market. Obviously, the regulatory environment to future-proof your business in terms of your where you come from, the current market outlook for investments, because as a startup and scale up, you're always in for the next round of investment, and the necessary steps to set up operation in the UK and become compliant to get good connections that are valuable for you entering here. So when it comes to the ecosystem exchange, it's a format of typically a 2-day in-person activity in London, potentially with a digital alternative to begin with for things that are good to have once you get over here. And the 2 days are divided often in a knowledge and insight day, and the second in a funding and growth day, and then potentially then with a delegation visit after. Testimonial, I think this company here, when we got to, I think this is Oxford, we have gotten great insight into the UK market that we have used to plan for our future expansions, both internally and in communicating to potential investors. We've also made connection with several other entrepreneurs and companies that we have stayed in touch with, and in a couple of courses helped each other with interest and info in certain areas. So it's not to underestimate the strength of coming together with the like-minded people and in the face that with like-minded problems and challenges as well. This is a little bit heavy calendar. I don't want you to have a look at it in detail, but just to give you a bit that we have almost 100 activities and of different calibers over the year. So we'll have the annual sectoral forums that could be life science, tech, etc. We have regional outreach because we've also seen that there's a lot of positive investment coming into the UK, and we saw that 80% were actually decided to be outside London. So it's important to have the footprint and understand how does it work in the Northeast, Northwest, and Scotland and Midlands. And the member network, so we engage them different business breakfasts in different formats. We just talked about UK political landscapes, understand how that could potentially end up. So that would be a series. We also have women in finance and women in tech as one also a topic. And for the businesses program, we are doing now in May what would be relevant maybe for this group when the memorandum of understanding that came into place the 27th of May is a 2 years anniversary. How far have we come? What have we achieved? And that would be health tech, med tech focused ecosystem exchange we do in conjunction with the Life Science Forum, where we gather 100 to 150 relevant delegates in a forum, and also give the opportunity to the medtech and health tech companies to pitch, or at least have not pitch as for getting capital, but to get sort of their exposure and connections and share their idea to a wider audience on the market. We will have ecosystem exchange, ClimaCheck, sustainable energy. We just discussed that with Business Sweden here. And we will do that together with the Impact Forum, where we will have a similar forum. This is slightly bigger. It's the Impact Summit in September. That will be up to 250 people in the impact space. And I think one of the things with the chamber is also with these forums and conferences is to be able to be speaking and connecting with people in a way that gives exposure. We had in the Impact now, a year ago, we had the King and Queen coming here that gave a lot of buzz on the market, and the same we had the Crown Princess Victoria and her husband Daniel also here now in November, and there were lots of attention around that. That could be good to benefit from. So this was just a quick one. So I thank you very much for giving me the opportunity, and please send me emails or any questions you might have, and we will also share the presentation for you if you're interested in joining or getting to know a bit more about what the Swedish Chamber can do for you.
Yeah,
here.
thank you very much, Anna. I think that the initiative, like who is going to be pushed in the next year, will find the Chamber of Commerce like a strategic partner in the near future. So thank you for that, and thank you for your information. And thank you all for keep still connected online. We know that we are already like go over time, so we apologize for that. But we still have like some 5-10 minutes to have like a brief discussion to those who have like the question in mind that you want to make to some of the speakers that we have today. So I don't know if we have any questions from the audience. No, well, if not, I have one that is part of some of the comments that I have seen like passing by during the conversation. And I mean, we are represented here in this dialogue, like the different perspectives dealing with the challenge of sustainable healthcare. And we just had like a very nice and meaningful conversation. My question is how to go from that meaningful conversation to the practical collaborations that you already mentioned already. I know that already Daniel and Rachel have very much clarity on how we can push forward this collaboration. What about the rest of the speakers? What do you think that we need to transform our meaningful conversations to practical collaborations? Thank you.
I thought the presentations were very interesting, and I think one of the things that, for me, as an architect and such like, is the fact that there's such a close link with mechanical engineering, the products, and certainly in the UK, the building costs. 50% of the building is engineering services. Now I know that's mechanical, electrical. Electrical doesn't have the same impact in terms of space within the built environment, whereas looking at the ones from the climate of if you're reducing the size of plant or reducing the size of ductwork, chillers, heat exchangers, things like that, that has a huge impact on the built environment. And I think it would be good to make more contacts with that. And it's interesting that, I think we need to make contact internally with the Institute of Mechanical Engineers, so it's good to, this is the first time I've seen anything, and this of your Nordic, but I think would be very interested in developing something with you.
I think also what I found quite interesting about this group of speakers is that you've got the NGOs, you've got businesses, you've got the academics, you've got the stakeholders all together. And I think how you move forward in this very complicated arena is you provide these opportunities for people to talk and discuss things. And everyone's willing to contribute. I think it's one of those few areas that's not that political. Everyone wants to contribute to this kind of aspiration net zero target. So I think the first step is lots of these opportunities to discuss, either in these online forums or face to face. And so I was very interested about your conference that you're setting up in October. So if you can circulate information on that, we would be very interested in coming along and seeing you and your colleagues face to face. So I think, and everything starts with a discussion and goodwill and everyone together. So I think this for me is a very interesting opportunity to see what people have done. So great.
Yeah, thank you very much. And just for those, please be attentive to our webpage. You will find more information on the oncoming conference in October, and of course of all our events. We, as you know, we don't only have these webinars. We have our training for sustainable healthcare, the introduction, and go to our webpage, find out what the other projects are happening. And please visit the World's Greenest Hospital, where you can find some of the solutions that were presented here, as well as many other aspects. I don't know if anyone else want to give a final word about how to push these collaborations between Britain and Swedish. Yes, Helen, please.
Yeah, I too, Ian, was very pleased to see the mixture of opportunities, I think, and I think you're absolutely right. Mechanical engineering plays a huge role in this kind of thing, but engineering as a whole, I think, is going to inform an awful lot of decisions in sustainable healthcare in the coming years. One of the areas I would be particularly interested to pursue with some of both the speakers and those people who are attending today is the issue of workforce. Where are we going to get the people to ensure that we can continue to drive sustainability across healthcare, both from a technical and a clinical point of view? And I think that is a really big conversation that we need to have both in the UK, where we have a very unique system of healthcare, but also more broadly across the world. And that, I think, is a conversation that we as a community here could really start, which would be great.
Thank you very much, Helen. And with these beautiful words, I think that we can conclude this event. And of course, on behalf of the Nordic Center for Sustainable Healthcare, thank you very much for your participation. And again, please feel free to contact us and be aware of our calendar of activities and projects. Thank you very much.